Good morning, grade 9. All right, in today's lesson, we're going to introduce a really important section called factorization. This section is really important because it's really foundational to a lot of other sections in maths. In fact, if you continue on with Maths Core until matric, you'll notice that there are quite a lot of marks in your matric exam that are based on factorization, say around 40. So that's quite a lot. Now, our main introduction to factorization happens in grade 9, and then in grade 10, 11, and 12, we add just a little bit more every time. So the stuff that we did yesterday with the highest common factor of monomials is going to come in pretty handy later on in this lesson. So let's just keep that in mind. Let's start with the most important thing. What is factorization? All right. So when we're talking factorization, we are going to say that it is writing an expression as a product of its factors. Now, what's important to understand here is what is the product. So we know that product actually means times, and we should know what factors are. So let's just do a real quick recap. So if I have the number 8, I could write it as a product of its factors by saying, okay, 8 can be written as 1 times 8. That would make 1 and 8 or factors of 8. Or I could say 2 times 4. So 2 and 4 are also factors of 8. So this is a bit of a silly example, but actually, if I wanted to factorize 8, I could write 1 times 8 or 2 times 4 because it's a product, so we're multiplying. It's factors because 1 and 8 are factors of 8, 2 and 4 are factors of 8. So that's pretty cool. Now, here's the real thing. The aim of factorizing. Now, why do we factorize? The aim of factorizing is, okay, to go from 2 or more terms to just 1. Now, it's okay if this seems a bit weird and it's not making much sense to you right now. We are going to do a number of examples and explanations about what this means. But let's talk about something here. We are saying that we can go from more than one term to just one term. That's the point of factorization. Now, please remember when we're talking about terms, if you recall from our extension exercise that we did, a term is separated by a plus or minus, meaning that when we create something that's a product, it's being times, so it's not separate terms. Okay, so 1 times 8 is technically one term because it's not being separated by plus or minus. All right, so that's the general idea that we have going on for what factorization is. And it's okay if for right now that doesn't make complete sense. What I do need you to understand is that we're going to be dealing with factors. And factors are things that when multiplied together will give us our original term. So for example, when we factorized 8, we said 1 times 8 or 2 times 4 because 2, 4, 1, and 8 are all factors of 8. And then we need to remember product is time. Okay. So now let's just keep that sort of in the back of our heads while we carry on with this. All right. The very first type of factorization we're going to deal with is to do with a common factor, which is why yesterday's lesson was so important. But before we even get to factorization, let's see if we can understand factorization in relation to what we already know. All right. So at the moment and during our extension activity, we were given stuff like this. Simplify or expand 7, open brackets, a plus 2, close brackets. Now, hopefully we remember that this means 7 times a plus 2. And we're going to just remember that we're going to distribute. So 7 times a is going to be 7a. And then we're going to distribute the next one. So we've got 7 times 2 times positive 2. So we're going to say that's positive 14. And then we always need to ask ourselves, can I simplify this anymore? Are they like terms? And hopefully you'll recognize that no, they're not like terms. This has an a in it and this has no variables in it. So that's as simple as it can go. So do you see that when we were told to simplify, to expand, we went from 7 times a plus 2. So that's one term. okay? And we ended up with 7a plus 14. Now, because of that plus sign, we know that we've got more than one term. So we went from one term to two terms. All right, now if you remember very carefully, factorization, I said, goes from two or more terms to just one term. So technically, if I wanted to factorize this, so let's see here, it says factorize 7a plus 14. I've got two terms. I want to go down to one term, but I want to make sure that it means the same thing. So let's have a look at this. What I'm going to do is I'm going to ask myself, what is the common factor between these two terms? So 7a and positive 14. And I say to myself, okay, step one, let's see the highest common factor when it comes to the numbers. So what is the highest common factor between 7 and 14? Well, hopefully you recognize that that's 7. Now, our second step, we ask ourselves, are there any common variables? Well, this one has an A, but this one has no variables. So that means no common variables, so we can ignore step 3. Okay, so I know that the common factor is going to be 7. Now, what I'm going to do, the next step is going to be to open up a bracket, okay? Because remember, I want the product of something. So I want to times things together. And I know one of them here is going to be my common factor that I pulled out. Now, what I need to do is I need to say, okay, let's take this first term and divide it by this common factor I pulled out. 7a divided by 7. Hopefully, you'll see that 7 divided by 7 is 1. So we've got 1a. And then we take the second term and we divide by 7. 14 divided by 7 is equal to 2. All right. We can just write this as 7 times a plus 2. Now, why does that work? Well, have a look. That's this right here. If I multiply this back out, I'm going to get 7a plus 14. 7 times a, 7a. 7 times 2 plus 14. So basically here, I've gone from 2 terms to just 1 term. Now, the way I did that is not terribly important for right this minute. It will be in the next example. But I want you to understand is that usually we've been told to expand or simplify, and we go from one term or products, things being times together, to more than one term. So just like we did in that first portion where we said simplify 7 times a plus 2, we went from one term to 2 terms. Now, factorizing, we started with 2 terms and we went down to 1 term. So what we can take away here is that factorizing is actually just the opposite of expanding or multiplying out. Okay, so what we've learned up until now over our extension exercise was how to expand. We were multiplying monomials with polynomials. We were multiplying binomials by binomials with the FOIL method. We were squaring binomials. So now we know how to do that. Now we're going to learn the opposite, which is factorizing. So factorizing is the opposite of expanding. So what we're going to do is we're going to learn the very first type of factorization that we come across. It's a really important type. This stays important all the way through to grade 12, and that is pulling out a common factor. So what we're going to do for each of these examples is we're going to look for a common factor. Once we've found that common factor, we're going to write it down, and then we're going to put brackets next to it. Then we're going to divide each individual term in the original question by that common factor and pop those answers in the bracket. Sounds complicated, but let's do a few examples so that it's simple. All right, so let's have a look here. We're dealing with 20x squared and minus 5x. See how I've included that minus, it's still part of that. So I ask myself, what's the highest common factor between 20 and 5? So again, we just started with the numbers. So the highest common factor, we're going to write here between 20 and 5. Well, I know that it's 5. So we can always see later on if you can use your prime factorization, I beg your pardon, to check me. And then the next step is check which variables you have in common. So there's an x squared and there's an x. So they both have an x in common. Now we ask ourselves, what is the lowest power of that variable? Well, here's a 2 and here's a 1. So the lowest power is a 1. So technically, my highest common factor there is 5x. So I'm going to write 5x And then I'm going to pop down some brackets, okay? So now we immediately have a product because it's 5x times whatever's in those brackets. Now the next step, so the first step was finding the highest common factor. The next step is dividing each of the terms in the original question by the highest common factor. So let's start here. I'm going to say 20x squared divided by 5x. Cool, okay. 20 divided by 5 is 4. And then x squared divided by x, well, we can use our exponent rules and say 2 minus 1, which is equal to 4 to the power of, times x to the power of 1. Or we can just say to ourselves, okay, at the top I've got 2 x's, at the bottom I've got 1, because at the top I've got x times x, and at the bottom I've just got x. Where are there more? Well, there's more at the top. How many more? Just 1x. So there we go. So we've got 4x. So that first term is going to be 4x. Okay, now we've got minus 5x divided by 5x. Okay, first thing I'm going to say to myself is a negative divided by a positive. I hope you remember is a negative. 5 divided by 5 is 1. X divided by x is also 1. Anything divided by itself is 1. So then we've got a minus 1. Okay, now that's factorized. That's it. We've got something times something, and that's it. Okay, what I want you to notice, these calculations over here that I've done over here, you don't have to write those out. Those are just in the beginning. As you get used to it, you're welcome to write it out. But eventually you'll be able to start doing this stuff in your head. Okay, now this bit is not part of your answer. You don't have to do this, but I'm going to show you a way that you can check if your answer is actually correct. Okay, so we've got this, and now we can check that it is right. So we don't have to worry that it's not correct. So let's take the answer we got here. We said 5x times, open brackets, 4x minus 1, close brackets. Let's quickly distribute here. 5x times 4x, well, 5 times 4 is 20. X times x is x squared. 5x times negative 1, well, a positive times a negative is a negative. 5 times 1 is 5, and then we've got that x. And if you look, that is, oopsies, that is exactly the same. So we know that our answer was correct. So if you were asked this in a test or an exam, this is the only thing that you would be expected to write this here in blue. All right, so let's see that that makes sense by doing another example. All righty, I'm going to hide example 3 before you get distracted. All right, so we were dealing with these two. We're dealing with 3x, and we're dealing with 3, basically, negative 3. And the first thing we're going to do is find our highest common factor. Well, we've got 3x and we've got 3, so we know that the number that goes into both of them is 3. Now, step 2, let's check if there are any common variables. Here we have an x, and here we have no x. So there are no variables that go into both. So let's get back here. We found our highest common factor. It's just a 3. So now I'm going to pop open my brackets. Now, step 2 is going to be take each of these numbers, each term, and divide it by the common factor that you pulled out. So let's start with 3x, and let's divide it by the highest common factor, which is 3. 3x divided by 3, well, 3 divided by 3, they either cancel out, you can say, or it's just 1x. But because we're getting really good at algebra, we know we can just write it as x. All right, and then we've got minus 3 divided by 3. That's the second term here. Oh, so then we've got a negative divided by a positive is negative. 3 divided by 3 is 1. So we've got the first term in the bracket is going to be x from that first bit, and our second term in the bracket is going to be minus 1. And again, we can check that we're right. So in order to check, and you do not have to do this in your tests or in your exercises unless you are told explicitly to check that it's correct. We're going to take our answer and say 3x minus 1, and we're going to multiply in. 3 times x is 3x. 3 times negative 1 is negative 3. And we can see here that these two are identical. So we know that this is correct. And you'll get 1 mark for taking out the highest common factor and 1 mark for the remaining correct numbers in the brackets after you've divided. All right, let's do one more example here and follow the same sort of chain just to make sure that you're with me. All right, the two terms we're dealing with are 4a squared and 20a cubed. Okay, highest common factor, we're looking for the highest common factor of the numbers first. So between 4 and 20, we can see that the highest common factor there is 4, because 4 goes into 4 once, so that works, and 4 goes into 20 5 times, so that works as well. Now, step 2, we're going to look at the variables that they have in common. This one has an a squared, this one has an a cubed, they both definitely have an a. Good. Now, third part of that is, let's assign that variable the lower of the exponents. So we've got a to the power of 2, and then we've got a to the power of 3. So we know that the lower of the 2 is squared. So there we go. I'm going to write down my common factor here that I've taken out and pop open some brackets. Alrighty. So now step 2 is going to be dividing each of these terms by the highest common factor that I took out. So let's start with 4a squared. Divide that by the highest common factor, which is 4a squared. Now, either you're going to be with me and you're going to be like, oh, the answer is 1. Or we can just break this down. 4 divided by 4 is 1. A squared divided by a squared is 1, because anything divided by itself is 1. So 4a squared divided by 4a squared is 1. So in here, we're just going to put down a 1. Now we're going to do the second bit. So we're going to say 20a cubed divided by the common factor that we pulled out. So we're going to say 20 divided by 4, well, that's 5. A cubed divided by a squared, and I hope that you can see that that'll leave us an a at the top. 3 minus 2 will leave us an a at the top, or alternatively, we have 3 a's at the top, a times a times a, and we have 2 a's at the bottom, a times a. So where do we have more? At the top, and how many more? Just the 1. Okay, and we know that this was a positive, beg your pardon, this was a positive, so this answer is also going to be a positive, plus 5a. Now, again, we can check this. We never have to worry that we didn't do this correctly. So here we go. Let's do my check. A reminder one more time, this check is just for me. It is not required of you in a test or exercise. It's just a really nice way of being sure you got everything right. Okay, let's multiply. 4a squared times 1 is just 4a squared. 4a squared times, oops, positive 5a, well, that'll be positive. 4 times 5 is 20. A squared times a, we add our exponents if we remember our exponential laws. And if we look at this, we can see that they are identical. So that is a really good sign. Okay, let's move on to our second last example. This is really just the same thing over and over again. We're just trying to add something a little bit different every time, just so that you can get a good idea of the type of things you could be expected to answer. Now, what's special about this one? Well, how many terms do we have? 1, 2, 3. So whereas up until now we've been dealing with only 2 terms, now we're dealing with 3 terms. But here's the thing, nothing changes. Okay, so let's write down the terms we're dealing with. A squared b, then we've got 4ab, okay, and then we've got minus 10, oopsies, that 0 was a bit sleepy. Okay, oh, my pen is tired, needs a cup of coffee. Okay, 10ab squared. All right, so step 1, let's find this highest common factor. Nothing changes here. Let's find the highest common factor between the 3 numbers first. We've got 2, we've got 4, and we've got 10. Well, the only thing that goes into 2 as well as 4 as well as 10 is 1 and 2. So our highest one is 2. Cool. Now we're going to look at our variables or our letters. So here we've got an A, here we've got an A, here we've got an A. Cool. So A is common between all three of them. Then I've got a B, I've got a B, and I've got a B. So B is common between all three of them. Now let's look at the lowest exponent for all of them. So here the exponent for A is 2, here it's 1, here it's 1. So the lowest one is 1. And let's look at B. So we've got B to the power of 1, B to the power of 1, and B to the power of 2. So the lowest is 1. So just like before, we're going to write our, oops, don't know where that C came from. Gosh, my brain is tired. All right, so we're going to write down our highest common factor, and then we're going to open up some brackets. Now, our next step, instead of us dividing this highest common factor just into 2 terms, we're now just going to divide it into 3 terms. So pretty much everything stays the same. So let's start with the first one here. 2a squared b divided by 2ab. All right, 2 divided by 2 gives us 1. A squared divided by a gives us just 1a left on top. And b divided by b just gives us 1, or we can say that they cancel out. So here, our first term is just going to be a. All righty. Now let's go on to the next one. Plus 4ab. Now we divide it by our highest common factor, 2ab. So 4 divided by 2, we know is 2. A divided by A, well, that's just 1, or we can say they cancel out. B divided by B, that's just 1, or we can say they cancel out. So our answer here is just plus 2. It's a positive 2. Alrighty, now let's do our last one. I'm going to just sneak it over here. 10ab squared divided by 2ab. And we say to ourselves, okay, 10 divided by 2 is 5. A divided by A, well, they're going to cancel out, so I'm not going to write any A's here. B squared divided by B, hopefully you can recognize that it is just B at the top, because at the top we have B times B, 2B's, and at the bottom we have 1B. So we ask ourselves, where are there more? Well, there's more at the top. How many more? Just 1. So this one is going to be, ooh, I nearly forgot a negative, right? So negative divided by a positive is a negative. So that's negative 5b. All right, and again, we can just check this. So how do I check it? Well, I just say, what's 2ab times a? It's 2a squared b. And then I multiply the next terms. So plus 2 times 2 is 4ab. And then the last one, it'll be negative 5 times 2 is 10. AB times B is AB squared. And would you look at that? It is the same. So then we're happy that we've done this correctly. All right, let's move on to the last example for this video. This one is unique and it does come up, so I've just pointed it out. If you want more information on ones like this, you can have a look in your textbook as well. So the key here is we're going to do everything exactly the same. The only thing that is different is you'll notice here, there is a negative in front of the first term. And up until now, we haven't seen that, okay? So up until now, we haven't been dealing with a negative in front of the first term. Okay, so how do we deal with it? Well, the only thing that changes here is that you're going to treat that negative in front of the first term as part of the highest common factor. I know it sounds weird, but bear with me and have a look. So our first term is negative 5a, and our second term is 10. So we can ask ourselves, okay, guys, what's the highest common factor? Now, the only thing that's going to change here is because the first term had the negative in it, we're immediately going to pull out a negative as part of the highest common factor. Okay, so if the first term has a negative in it, we're going to pull out that negative as part of your highest common factor. So now we ask ourselves, between 5 and 10, what's the highest common factor? Well, it's 5. We'll check, are there any A's? Are there A's in both of them? No, there's only an A in the first term, so there is no variable as part of the highest common factor. All right, now everything carries on as normal. Now we've just said our highest common factor is -5. We pop down some brackets. So that was step 1. Step 2 is now going to be divide each term in there by the highest common factor you pulled out. So the first term was -5a. We're going to divide it by -5. Now we need to be very careful with our signs. A negative divided by a negative is a positive. 5 divided by 5 is just 1. Or we can say they cancel each other out. And then we're left with an a. Again, we're good at writing our algebra nicely, so we're just going to write this as a. So in the bracket, the first term is going to be a. Okay, then we've got plus 10. Our wonky little 0 again. Shame. Plus 10 divided by -5. And we're going to say a positive divided by a negative is a negative. Remember the two friends, one's happy all the time, one's sad. That's not a good friendship. That's a negative relationship. 10 divided by 5, well, that's going to be 2. So in here, we're going to have -2. Okay, so this example was really important because of this negative. If you have a negative in the first term, take it out as part of your common factor. And once again, we can check that this is correct. Remember, please, the stuff I'm doing in green is not necessary for you to do as well. It is just a nice way for you to check that you are doing this correctly. Okay, so let's see if my pen will play nicely for this last example. Okay, -5 times a is going to give us -5a. And -5 times -2. A negative times a negative is a positive. And 5 times 2 is 10. And there you can see that we got the same exact answer as what was in our original question. All right, guys, this is a really important method for factorization, and it's obviously the first one because it's the most important one. It will always be your first point of call. If you're given a factorization question, the first thing you're always going to want to do is check if there's a common factor. So I hope that you understood this. If you haven't, please go over the video slowly one more time. Make sure you've gone through the examples with a pen and paper and try them yourself. If you are still having trouble, just drop me an email or drop me a message in the classroom and I will get right back to you as soon as I can. Okay, guys, now head off to do your exercise. Good luck and let me know how it goes if you're struggling with anything. Have a great day.